Hello, this is Justin Kaltenbach with Health IT Squared, and this is part 3 in our OHMPI series. We are presenting on Oracle Healthcare Master Person Index. In part 3, we're again doing product demonstration, and we're showing configuring the master index in this edition. We're going to take a look at the design and development environment for OHMPI and get a good idea of how the product is configured, what goes into setting up and customizing OHMPI, and how we do some of the common things that occur during implementation, such as adding fields or removing fields that we don't want, as well as adjusting maybe the weights, the ranks, setting how the phoneticizers take place. Again, there's many different options that we'll see as we go through this demonstration. If you haven't looked at some of the other presentations, I encourage you to start with one, which is just an overview of the product, and that'll help give you good background on OHMPI if you're not as familiar. All right, so I'm going to go ahead and jump right into my demonstration environment, which is running just locally on my laptop. I've got the product opened up here, and its product name is project name is OHMPI underscore patient underscore member, and I can see a few different subfolders here. There's also 2 additional projects that exist, and they come actually automatically when we generate an OHMPI project, and you'll see one is called or ends in EJB, and that is essentially is a Java application, as well as one that ends in WAR, which is a web application. And so the Java application and the web application projects are actually automatically created from the root project for OHMPI when we generate the files or we build the project here. Okay, so underneath the main OHMPI project, that's where we're going to spend most of our focus, because again, what we do in this area determines the components that are generated in the other 2 projects automatically. So first and foremost, we see the structure. We've got a folder here which says configuration. Underneath that is a bunch of XML files, and that's actually where the configuration for OHMPI is stored. I can go into any of these files and just double click, and I get a view of that in my editor pane on the right side of the screen. And you'll see each of these different files, as described in the documentation, controls a different aspect of the product and when it's deployed. So, for example, we're in midm.xml right now. This is what controls the different displays and screens when we're on Master Index Data Manager, the web application. And that's something I showed in part 2. So if I scroll through this quickly, and you can see it's all XML-based data, and in there, again, a variety of options on what we see in some of these screens. So for some folks, accessing an XML file, editing it, and managing a project this way may be daunting. So luckily, OHMPI has a graphical configuration menu. So if I right-click on the configuration and select Edit here, I'm presented with that GUI, and it represents the configuration of this project in a much simpler fashion, much easier for me to work with as a manager of this product. So, for example, on the left side here, I see the object definition. These are the structures or nodes that exist in my particular implementation. First, we list the basic fields in the root node, which is patient, and we have things like name and social, date of birth, gender, marital status, and so on. But then we also have looping elements down here represented on the bottom part, and within those elements, what fields exist there. So alias, address, phone number, insurance information. All right, so I'm going to collapse that and jump back up. So you'll see that when I click on the root node of this project, I'm provided with project level properties, whereas if I click on a particular field, I get field level properties. And so each field has its own object settings meaning the actual field, as it exists within the structure. What options do we have in there? So what's the data type as an example? Is it part of the blocking that takes place, which is a step in our matching process, is actually step 1 of the matching process. Is it a required field? What field size do we want to set? Is it updatable? And so on. So you see some of the options here. Also, some of the fields have patterns assigned to them. So if I go to, actually social is a good example. Pattern, it needs to be a 0 through 9 value for 9 characters length. And now I'll represent what's shown on the screen for MIDM, which is Master Index Data Manager, the web application. So on our user interface, how do we represent this field? What's the label next to the form field? And then is there an input mask or a value mask? So an input will help us automatically put in things like dashes, which you can see as here, digit, 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 dash, and so on. The value mask also saying, hey, whatever is input in there needs to meet this specific criteria. All right. So again, I could click through some of these different fields, and we see different options there. This is somewhat representative of the structure as it comes out of the box. I can add fields or remove fields quite easily, and it's simply done by right-clicking where you want it, and you add a new field, or you can even go and delete. So when I hit new there, it presents me with an option, and oopsie, it doesn't like a space. I forgot about that. And so now I've added a new field in the structure. If I don't want a new field, I can always delete that. And that goes for any of the other fields in the structure. I can select them if I find that they're not necessary, such as driver's license state. And I can go ahead and just delete that and confirm. All right, very simple. Let's go back up to the root node and look at project level properties. First off, we are on the matching tab, and within there, we're showing a couple different lists here. One is what fields have a match associated to it or are being used as part of the matching process. Believe it or not, not every field is part of that. So we can look at what's done in my system as well as customize if we'd like to add or remove. So as an example, I can see on the patient date of birth field, we're using a match type called date. And so what does match type mean? Well, it actually just brings me down to the second list here, which we can essentially normalize the different match types so they can be applied to different fields. So, for example, we have one common match type used for date fields. This could be date of birth, date of death, as well as any other particular dates that may be important, such as a date of admission or date insurance expires or so on. So in this date match type, we see what options there are. The most important one is to look at what function executes for that match type. So the functions are our comparators, and these are tied and part of the algorithm associations in our system. And what we're essentially saying is what algorithms are being executed when we are calling this match type. So if I scroll through this list, you can see that the product comes with a number of different algorithms, and all of them provide different unique aspects to the data. And so if you look through the product documentation, you'll see a very detailed description of what functions or comparators should be applied in what scenarios. So certain algorithms may be more applicable than others just based on the data and the data type. So we've got some optimized here, or several optimized here, and already selected based on these fields. But if you're adding your own custom fields, you're going to need to make some of these decisions. So it's nice to know that you've got a lot of different options here and how you compute the differences between values when it's going through the matching process. So in this case, we had a date comparator that we saw here, and then down at the bottom set of fields for these options in that matching rule. we look at what are the parameters that we're passing into the algorithm as it does its computations. So there's agreement weight and disagreement weight, and those are essentially parameters, meaning if there is an exact match, it would increase the overall score by 10. If there's a complete mismatch, it would decrease it by 10. Now, because these are parameters, the comparator actually calculates a value based on that. So it doesn't have to be, or it will not be 10 or negative 10, but it could be anything in between and including 10 and negative 10. There are also some additional parameters here that are passed into the algorithm, and I would just recommend you look at the product documentation as each of the each of the comparators and algorithms have their own sets of parameters that can help you fine-tune based on your data sets. All right, so I cancel out of that. If I scroll through some of these other ones, we can see that there's even more simple comparators like an exact character to character to character comparator, and again, each field has its own weights, a high and a low, or agreement and disagreement set. So, simple to view this data and configure. If we want to add additional ones, we can do so simply by going to the field, such as account, and setting the match type in this pull down. So actually, match type is already set in here. Let's see if I can go to death here. It should be just a death indicator, and there's no match type set, so I can use this pull down to choose one if I wanted. All right. The high and the low threshold settings are also displayed on this tab. The low in this case is set at 7 1/4, the high at 29.0. So what that means, if you can remember back from my first presentation in this series, is if the match score is below 7.25, we consider them two separate records. If it's above 29.0, we would consider these pair of records or a pair of records the same person, and automatically link them or flag them for review in the event that we have a rule set to process or manually review automatic matches. All right, moving on to the query tab. I actually want to jump down to the bottom portion of the screen and show the blocking queries. And the blocking queries are what execute in step 1 of our matching process. So if you saw part 1 of these presentations, you remember I broke it down into 2 steps. Step 1 was a very loose candidate search, meaning we take this incoming record or query and very loosely match it to records in our index. And so in this step, we can see how those loose matches have taken place and what the breakdown is. So for example, this list of block definitions will execute in sequence, and if a match happens on any of these, it will include the record that matched or records that match in a subset that can then be processed in step 2. So if I just look at one of these, such as the social, we can basically say, hey, we're trying to match from the source system, the patient social, to the field within OHMPI, which is the single best record, patient social. That's an example of a block rule that uses one field to match, but here's one that uses 2 fields to match, a first name phonetic and a last name phonetic. Or we could have an example where there's 3. There's a match on first name, date of birth, and gender. And all of these, when they execute, are utilizing normalized versions of the data. So if the first name comes in as John, but in the index it's Jonathan, that's not a problem. The routines automatically know to normalize when they go through these queries. So again, step 1 of 2, and we see the block definitions here for step 1, the loose candidate search. So after that processes and gets us in that subset is actually when it falls back to the matching rules that we saw here a moment ago, where we have agreement and disagreement values for each field being computated. All right, so we'll move on to some of the other tabs here. We can see what fields have a standardization engine associated to it, and this multi-domain selector is sort of a standard setting, but you can see that we've got domains set for a variety of locales, including Canada, Mexico, US, UK, France, Australia. And what we try and show here is that this is a very modular approach, and that we can select different domains and different locales, and when they're even updated or added into subsequent releases of the product, we don't have to go and reconfigure and reinstall everything. It's just a different option or an additional option that we can select here. We can also see how the product is breaking down things like the address, and I chose to look at street type, and so we can see the subcomponents that exist in the address and how the OHMPI product is breaking apart those addresses. Just gives you an idea. We don't commonly go in here and change things, but it's good if we ever need to, that it's all graphical to do so. Normalization routines, what fields do they execute on and what normalization is taking place? So again, we can set the component and the definition. So first name, middle name, last name, title, gender, gender suffix are all of the different components that we can run normalization on. Again, we can define it by locale. So we standardize, in this case, we're seeing the standardization for the first name and last name, both in the regular fields as well as the aliases. The tab up here for phoneticizing fields, you can see what fields are phoneticized in the product, as well as what encoders are available. Very modular approach. So I can hit edit here, and we see that the encoders that are called really just boil down to Java classes or Java libraries. So we're using, in my example system here, both SoundX and Nisus, and two very common algorithms that are used for phonetics. But there's also several others in here, such as additions specific for locales, or even a refined SoundX, metaphone, double metaphone, and then some like we see here for other international locales. All right. Lastly, deployment. Very simple. We just can set transaction mode, which is important for how we interact the application with the database. All right. So now I've shown this in the GUI, and I mentioned earlier on that our configuration is driven all off of files. So if I go into some of these other files, we can see where the data, or I should say where the configuration options are persisted if we make those changes or use that GUI to update or add something. So in this case, we're looking at the object file, and this is determining what fields exist. Very straightforward. It's all XML data. We can see a quick relationship structure at the bottom here. But every field has a set of subfields or sub-elements that describe it, such as what's the name, what's the data type, what's the length, is it updatable, is it required, and so on. Query.xml is where we have our block queries, and again, this is the part of step 1 of 2. We looked at MIDM a little earlier, and maybe master is a good one because this has just some master configuration options. So at the end of the day, it's really based on your implementation team's technical abilities on whether or not they go into the configuration file via GUI or do they go into configuration via the actual XML files. But we can do either or, and the change is round trip. So if I make updates by either method, there's really no effect or negative effect to those using one or the other. Now, when we generate an EMPI project, it runs through several processes internally based on what's in the configuration files here. to automatically help us define the remainder of or the necessary components for OHMPI. For example, we create database scripts as part of that generate index files process. Database scripts are what are then executed on your database of choice, such as Oracle, MySQL, or Microsoft SQL. And these scripts will create the tables and associations and indexes that are necessary to run the product. You can see there's also one here called Codeless, which pre-populates some of the tables after we create them with some of the default values that we need. And then systems. This is when we actually modify, usually during implementation, and that is to create different records here for what source systems exist. So we would do something like a copy and paste and just modify these. So now we can input the different source systems just by doing a simple SQL call. All right. Amongst the other files that I mentioned that are automatically generated, two of those I refer to are actually projects. One is the enterprise Java Bean, or the actual Java executable code that goes onto the application server. We don't really go in here or edit anything as it's all automatically generated and there's no need to modify. And the same goes for the web application. All of the files are automatically generated, including a large set of JSP pages. So all of the web pages that we had in our master index data manager, including what fields are displayed on those screens, anywhere from the inputs to what's listed in results and data forms, is all automatically generated and done as part of the generate process. So we can view these, but it's important to note that it's auto-generated. All right, one of the last things I want to show is the standardization engine. And in the standardization engine, we can look at some of the different libraries that come with the product, and you can see that they're locale specific. And in these standardization libraries, we can look at a couple examples first. Let me just pull up the given name. That's what I want. So this library is an example for given names. Does the standardization when we've got variations of a particular name. So let's scroll down to Adrian as an example. We can see that on the right-hand side, the standardized name of Adrian can have multiple variants, which is on the left-hand side of that pipe delimiter there. So Adriana, Adrienne, Adriana, Adrienne, again, we can see that they're spelled different ways. Adria, Adrienne, and so on. So this goes for names that maybe sound somewhat alike or look alike, as well as names that don't, like Bessie and Elizabeth. So a phonetic engine is not going to catch something like Bess and Elizabeth, but our standardization or our normalization engine will. So that was given names. We do the same thing for surnames or last names. And in a lot of cases, this helps us get common misspellings. You've also got the same for salutations and titles. So we can create as many of these as we'd like, and we're just looking at a few simple example items that come out of the box. But we can also extend these lists by adding records just simply via text. And do something like that. Oops, one little character there. And if we want, I would just save that and let it go into the system. So when I do edit any of the records or add records under the standardization area, I actually would want to rerun the generate option here in the project or main project. And what that'll do is make sure that those changes I've created are existing in the deployable projects, which are the EJB and the WAR file. So we looked at some examples there for name, but we've also got a couple that we can look at on address. So I go to resource. And address is one that I don't typically ever recommend modifying or changing, but if we look at this master clues file and the patterns, what I want to show is how the product has a very extensive set of data in it for recognizing addresses and their variants. And these pattern files or these pattern configurations help it process the data in a very efficient way to be able to break apart an address as it exists in hundreds, if not thousands, of different forms. And so these are all examples of different forms of an address. And these aren't specifics for an address, but really more so definitions for the algorithms to recognize how an address can vary for a particular locale. And you see in this instance pull down here, or this instance structure, folder structure, that you can see we've got many different locales pre-bundled with the product. And just scroll through quickly, you see there's thousands of lines in this particular configuration file. Again, patterns and some of the areas here under the address are ones that we typically would not recommend going into as a client, but that's something that's bundled with the product. And I like to show it because it really shows some of the depth that's been researched and input into OHMPI, so it can make very accurate and powerful matches. And then lastly, maybe highlight a couple things here that I probably didn't and should have touched upon in the beginning, but the overall IDE is based on NetBeans. It's open-based development environment. The projects themselves just fall back to a file folder structure. So if I tab over, I can see where it's stored on my hard drive here. And I can check in and check these out using source control. Any common source control system is supported by NetBeans, so you've got a lot of options there for how you'd like to do things in your own particular environment. All right. So that concludes my overview of the design environment and coverage of how you configure and update and work with OHMPI. What I'd encourage you to do, if you have any questions, feel free to reach out. I'll put my contact information back up here in a second. Just to recap, Health IT Squared is an Oracle Go partner, and we specialize strictly in healthcare. OHMPI is something we've been around for over 10 years now, and we're very well versed in it. So if there are any questions you have, or you'd like to see a product demonstration of OHMPI, please reach out. And if it even goes beyond OHMPI around other healthcare questions such as infrastructure and technology choices, or just how to implement certain things, we've got a variety of services and software that we can bring to the table and discuss with you. So we hope to hear from you. My contact information displayed once more. And I'd like to thank you for watching, and please tune in for the last part, which will be part 4. And that is a very technical dive into the product. So we'll look at the underlying database structure and some of the more technical aspects of how we interact with OHMPI. Thanks a lot, and have a good one.